one for body 2. They are moving with the same acceleration because they are moving as a system, assuming that the curve doesn't stretch. So if the curve suffers a stretch, they will have different acceleration. But if the curve doesn't stretch, they will have the same acceleration. Okay. The next step is to find the algebraical addition on body 1 and on body 2. On body 1, I am looking for what? I am looking for the acceleration. But I need to know, I need to disclose what is the net force along X on body 1. Tell me what will be the net force on body 1. F minus T1 equal to what? M1A. The second? T2, because T1 and T2 by the action and reaction law are the same, I just will label T1 and T2. Sorry, T, right? Because they are the same based on the Newton's third law. So F minus T equal M1A and T equal M2A. Got it? These are the two equations from my two free body diagram. The force is positive because to the left is positive. I mark it here with this arrow. Okay. How many unknowns?
Two.
How many equations? To solve a system of equations using either substitution method or elimination method. It's easier in this case, elimination method, right? We add both equations. We get that F is the summation of M1 plus M2 times A. Which what you are saying is that this force is pulling the two objects, assuming that the curve is massless. So the curve doesn't have mass. If the curve has mass, you will put it as a third object. And you have to have three equations. But in this case, it's massless. So what you are doing there is pulling the two objects together. Like pulling one object, which is equivalent to pulling one object of how many kilograms? Which is? How much in that equation? 22 kilograms. So basically, that's what you see. When you're pulling two objects, like a truck is pulling two trailers, the truck is pulling like the mass of one trailer, which is the combination of the two trailers. An equation. It's the same. But sometimes it's better to disclose the equation because sometimes you will find the tension and you will need to find the tension. With this equation, you don't see anything related to the tension and it's very difficult to find it. So it's better to have this and you will find the tension. Because the question not necessarily will be just only to find the acceleration. It can be find the tension as well. Okay, so the acceleration will be equal to what? The force divided by M1 plus M2. Once you have the acceleration, what will be a better equation to find the tension? The first or the second? You can in either one, but the tension will be easier. So the tension will be the force M1 times the acceleration, which is the force divided by M1 plus M2. This will be the tension. Okay, this is the first example with two objects.
Is it M1 or
I get this M2. M2. Okay. So this is one example where we have two objects. Another example with two objects will be the Atwood machine. Atwood machine is basically the working principle of the elevator. Let's say that we have an elevator attached to a pulley here. The pulley will have an elevator with the people inside and the counterweight. This is the working principle of an elevator. So this is the mass of the elevator This is the mass of the counterweight. And the question is the same. Typical question will be to find what? Assuming you have an elevator and counterweight, I'm making an analogy to the previous question. What do you think that I will ask? Find the acceleration, find the tension in the core. Because the pulley is massless compared to the elevator and to the counterweight, we can neglect the mass of the pulley. If the mass of the pulley counts, you cannot say that the tension 1 and tension 2 will be the same. They will be different. And we need to consider the rotation of the pulley. That will be in rotational motion. But let's now take it out of the picture, and let's take the motor out of the picture as well. Okay, the working principle of this is based on the Newton's second law. The forces here is tension, mg of the elevator, mg of the counterweight. And this is my row diagram. Assuming that this is heavier, so the elevator and the counterweight usually will be approximately the same weight. Approximately. But when the people enter to the elevator, what will happen? It will go down, right? This will break down a little bit so the people won't go in free fall. And that's one of the advantages. And 2, when it's going over, the motor doesn't have to do too much force because the counterweight is helping. Got it? So this is the idea of the motor, the elevator, and the working principle of the output machine, which is the way that they call this elevator counterweight. Okay, so getting the acceleration, we go to the Newton laws. Since this is going downward, my free body diagram for the elevator, how it looks like, or my equation. Just now let's start getting faster. So how will look my disclosure? This, I am in this step now. Finding the algebraical addition, so I don't have to write anymore sigma f equal ma because, you know, we're already getting expertise. So what will be this? Find the algebraical addition on the desired axis for the elevator. Tell me what will be. MEG minus tension This is my first equation. What will be my second equation?
MCG minus
In which direction is moving?
so
Upward. So what will be? Tension minus mcg equal to what? No, the negative, we already taken account the direction for that matter, just to all acceleration are positive, are in the direction of motion. MACA, this is my two equations. Again, tension cancels out, same thing that we have there. ME minus MC times G divided by ME plus MC. This will be the equation for the elevator and counterweight for the altitude machine. This equation, we will prove it here, or we will work with this equation in our lab. So one lab will be the altitude machine. So remember that equation, which means that the acceleration is directly proportional to the difference here of the weight and inversely proportional to the sum of the weight. We will work with this equation. Remember when I said, remember this equation in the lab, we have to prove that equation.